In this question, we're given a function f of p is equivalent to 2 minus the root of p. It says what is the domain of this function. So we want to get the domain, and in order to get the domain, we don't want to get unknown values, and we don't want to get negative root. This is two main things that we don't want to end up with. And if you look to this function, since we don't have denominator, it's not possible to get the unknown function, but it is possible to get a negative square. So if we look at the p, we know that p must be bigger or equivalent to 0, because if it's minus, then we're gonna get minus 0, minus square, which is we don't want to get that in our domain, so it must be either 0 or bigger than 0. So this is our first side, but we could go, it could be 0 or bigger from 0 and goes all the way to the infinity. But the problem with that, if we go all the way to the infinity, this value will grow bigger, and what we gonna end up, because we have over here 2 minus, so minus belongs to this value. This means if this value goes bigger and bigger, we're gonna end up with a negative root also. So we don't want to end up with negative root. So what we want to do is get the biggest value of p that will give us 0 or less, or it will give us 0. And we're also gonna accept any value for p that will give us a root of less than 0. So in order to do that, p must be equal to 4 or smaller than 4. It can't be bigger than 4, because if our p was bigger than 4, if p bigger than 4, what will end up happening is 2 plus, let's suppose we had 9, right? So what's gonna happen over here? The root for the 9 is 3, so we will end up with negative root. We don't want to end up with that. Or maybe we had something like this, 2 divided by, let's suppose we had 5, and the root of 5 is 2, or I think it's 2 or something, or it's bigger than that, so we will also end up with negative. So that's why we don't want our p to be bigger than. This is our domain.